Okay, so what I'm going to be talking about is the different aspects of test-driven development and the different kind of styles that are within it and different conventions that are generally followed within test-driven development. TDD, as another way of calling it, is when you focus on writing only the code necessary to pass tests written by the developer. And by doing this, the designs can be cleaner and clearer than other methods of development. There's a lot of different phrases that people use. One of those phrases is "keep it simple, stupid," which is one of my favorites because it's referenced by one of my favorite TV shows. And what it basically means is keep it simple. Write only what you need to pass the test. Don't add any other fluff just to make it maybe just to look better, to seem better, but just keep it simple. Only write the code needed to pass the test. And another common saying is you aren't going to need it. And this is really helpful for me because I tend to write a lot of code that I want just to make the program look better, or that I want to produce a fluffy result, as I should say, just something just to add some extra pizzazz. But most of the time, I'm not going to need the code that I write, but just the code that I need to pass a test. And then fake it till you make it is another common one, and that refers to how when you first write the test, a lot of the time the programs aren't going to run because it's just a test that you've written. And so by faking it till you make it, you're assuming that you're going to write the code that's going to pass those tests eventually. So you just fake it until you make it. Write the code until you do pass those tests, which is another common saying. Um, and by doing this, it allows the developer to focus on the design pattern. Helps to focus on what is important because if you follow those tests exactly after creating the design pattern to be followed, it helps to write only what is necessary and what's important to have the program run. Another thing, when writing feature first code, that's opposed to test driven development. This is about the opposite side. There's a tendency by developers and organizations to push the developer onto the next feature, onto the next thing to bring in to the table, which neglects testing entirely if they're just continuing to go to the next feature, which isn't good because testing is important and makes sure that the program's running right. And another thing to keep in mind is you're supposed to keep the unit small. And by unit, I mean a class or group of related functions, which, in another word for related functions, is module. And by keeping the unit small, it helps to reduce the debugging effort. Because those units are small, it helps test cases to be easier to read and easier to understand. And by keeping those units small, it helps also to have self-documenting tests. And by self-documenting, I mean because those tests are so small, they almost speak for themselves what the test does, which is super nice in testing because you might as well have something easier just for writing so many tests, and there's just a lot of code. And this just helps make things a lot easier to understand, a lot easier to get as a whole. There's also some best practices for tester development, and this is a picture of Dwight Schrute from The Office. As I was saying earlier, keep it simple, stupid. Just write down what you need, write the code that you only need to pass the test. Keep it simple. And this is the man that learned it himself. And so some best practices is creating a test structure. And for the test structure, there's 4 parts. There's a setup, execution, validation, and cleanup. And for setup, it's putting the testing environment or the testing system in the state needed to run the test. So it's pretty much preparing the test to be run in the right state. Execution, second piece. This is really triggering or driving the test to perform the targeted behavior and to capture all the output from those tests. Maybe it's return values, maybe it's output parameters. This step is usually pretty simple because it just runs the test needed. The third part is validation. And validation is ensuring that the results of those tests that were just ran are correct. These results may include explicit outputs captured during execution, or maybe it's state changes in the testing environment. And then the fourth and final piece of the testing structure is cleanup, which is almost the opposite of setup. It's just tearing things down. And this is restoring the testing environment to the overall testing system before the test perform the execution and validation. This restoration permits another test to execute immediately after this one, so it helps to write tests continuing this. And another best practice for tester development is separating the setup and the teardown logic. It helps to prevent the repeat information as well. But by separating the setup and teardown logic from the actual test execution and validation, it helps to not repeat information because multiple test files can use that setup and cleanup code rather than defining it more than once in all those setup, execution, and validation pieces of code. And also, developers developers that use test-driven development are also expected to not to follow these anti-patterns. And the first one that I have here is decoupling tests from each other. And I use the term decoupling because we've talked about it a lot with Dr. Fontelis. And decoupling, in this sense, means making sure that each test is independent from one another. So making sure that one test doesn't rely on the values of another test to be run correctly. Each test should be run as its own entity, and it shouldn't matter what other tests are written for this. A test also should not worry about implementation details, because while it may differ from program to program, the results should be the same. So it doesn't matter if another developer is using your test, because the results should be the same, even though the implementation may differ. There also shouldn't be any interdependent tests. For example, for me, I've done this before. I've had interdependent tests, which have changed the value of some Boolean variables that I set, which can cause incorrect results, which can result in failed tests, which isn't what we want as developers. And make sure that you don't test when practicing test-driven development. The best practices, it's best not to test precise execution behavior, timing, or performance. Once again, it's best to keep tests consistent, and the way that they should run all the time be the way that they run all the time, not have it rely on performance or maybe even a timer. That's just not good for tests. And so that is what I have for best practice.